Good day, students. In this lesson, we will study the conservation of mechanical energy. You will learn how energy is transformed and the principle of conservation of mechanical energy. In mechanics, energy is divided into two kinds, called kinetic energy and potential energy. That is, mechanical energy is equal to kinetic energy plus potential energy. Kinetic energy is the energy a body possesses by reason of its motion. Examples include a body falling under gravity, wind in motion, moving electric charges. The list can go on. The kinetic energy of a body of mass m moving with a velocity v is half mv squared. Potential energy. Potential energy is the energy a body possesses due to its position or state. A body at rest has stored energy that can do work when free to move. For example, a stone placed on a table has potential energy. When it rolls and falls, this energy is converted into kinetic energy. On hitting the glass cup, the energy is transferred, causing the cup to break. The stone resting on top of a table has gravitational potential energy due to its height above the ground level in a gravitational field, the Earth. For many purposes, the surface of the Earth is taken as being the zero level of gravitational potential energy, so that a body of mass m at a height h above the Earth's surface possesses potential energy as mgh, where g is the acceleration due to gravity. Other forms of potential energy include elastic potential energy in spring, electric potential energy such as electric charges at rest in an electric field, chemical potential energy which are released when petrol, wood, or other fuel sources burn. Energy can be converted from one form to another. Examples include electrical energy to mechanical energy in an electric fan as its blades rotate. Electrical energy to heat energy in an electric iron. Heat energy to mechanical energy in a steam engine. The law of conservation of energy states that energy cannot be created or destroyed, but it can be transformed from one form to another in a closed or isolated system. Isolated system simply means no external force such as friction acts on the system. Total mechanical energy is equal to kinetic energy plus potential energy is a constant. This means as potential energy decreases, kinetic energy increases. Also, as kinetic energy decreases, potential energy increases. Examples of energy conservation can be illustrated in 1. A falling body. 2. A simple pendulum. A falling body. Imagine throwing a ball straight up into the air. What really happens to its energy as it moves? At the moment you release the ball, it has speed, which means it has kinetic energy. But as it rises higher, something interesting happens. Its speed begins to decrease because of gravity. Eventually, the ball reaches its maximum height. At this point, its velocity becomes zero. It is momentarily at rest. So what about its energy? At that highest point, all the energy is now stored as potential energy. Now, as the ball begins to fall back down, its height decreases, but its speed increases. This means potential energy is decreasing, kinetic energy is increasing. Consider a body released from rest from point A at a height h above the ground. At point A, the body possesses only potential energy since its velocity is zero. As the body falls through a distance s to point P, its potential energy gradually decreases while its kinetic energy increases. At point P, the body possesses both potential energy and kinetic energy. Just before it reaches the ground, its height becomes zero and all its energy is converted into kinetic energy. Thus, at A, energy is entirely potential energy. At P, is partly potential and partly kinetic. At the ground, energy is entirely kinetic energy. Another example of the conservation of mechanical energy is a swinging pendulum. Points A and E are the extreme position, while C is the equilibrium position. At A and E, the bulb is momentarily at rest, so its velocity is 0 and its kinetic energy is 0. At this point, the bulb has maximum height, so its potential energy is maximum. As the bulb moves from A towards C, its height decreases, its speed increases, potential energy decreases, while kinetic energy increases. At point B, an intermediate position, the energy is partly kinetic and partly potential. The total mechanical energy remains constant. At point C, the bulb has maximum speed, so kinetic energy is maximum. Potential energy is minimum, that is 0. As the bulb moves from C to E, kinetic energy is gradually converted back into potential energy. At point D, energy is again partly kinetic and partly potential. At point E, all the energy becomes potential energy again, equals to its value at A. This process repeats as the pendulum swings back and forth, demonstrating that the total mechanical energy, potential energy, plus kinetic energy remains constant throughout the motion, provided there is no energy loss due to friction or air resistance. This is called the conservation of mechanical energy. Once you understand this principle, you can explain motion in falling objects, projectiles, and even machines. And that's the power of physics. In our next lesson, we will take examples on conservation of mechanical energy. Thank you for watching.